Hello everyone, my name is Liao Wen. Today we're doing a unsupervised machine learning using the World of Warcraft game avatar data. First, let's make a brief scan of our project. The World of Warcraft game is a MMORPG online game. The goal of our project is to explore the distribution of the game characters based on their race, level, class, guild, and other influential factors. Besides this, we will provide recommendations of character building for new players. The size of our dataset is 57.73 megabytes, containing 1 million records and more than 3 meaningful variables. But the disadvantage is the large data size, which could cause heavy load on machine performance, especially during the clustering process. Based on what we learned from class, the tools we're using is Python on Jupyter Notebook and Gephi software, which is a open source network analysis and visualization software package. The main content of our project include 4 parts. First, a exploratory data analysis through unsupervised machine learning. Second, build a simple recommender to help new players to choose their classes and races. 3. K-means clustering. 4. Graph centrality. So we already have our homepage pulled up, so let's go ahead and load our project. I already have this project completed. For saving some time, here we're gonna go over again through all the steps. First, let's import Panda library and necessary components. Import the data, then we check the missing value. There's no missing value showed up, but we have to recheck because some of the data might look like missing value, but they're not. We choose to display the first 5 rows just to show the basic structure of our data set. The row index indicates the observations of records through every timestamp. We can see the timestamps are very intensive. If you change the row displaying value to see more records, you will find a large amount of observations within exactly the same timestamp. So this timestamp is meaningless for our data analysis. So let's go ahead and drop it and pull up the results. The next step is to collect the categorical variables. Let's create a bar chart to show the distribution of the race data. We can see the Blood Elf ranks on top of the observations because most players consider Blood Elf a good-looking race since the beginning of World of Warcraft. Next, let's check the class distribution. We can see the top favorite class is Hunter, Mage, and Warlock. This is exactly what happened in the game in 2007. And let's pull up the zone distribution. The first one is Shatta City. In 2007, you go to Shatta City as much as you go to your office. Players go there for trading, doing quests, learning class skills, etc. And Agrima is Horde's capital city. Stormwind is Alliance capital city. Yeah, there are 2 different factions in this game, just like Decepticons and Autobots in the movie Transformers. Our next step is to convert the categorical data into numeric values because we will use these data for further analysis, such as clustering. Then we show all the columns in the converted dataset. All 3 categorical values are separately displayed in numeric values instead of showing the collective number of occurrence. But we have to remove the large amount of zeros because we only need the actual physical occurrence of those characters. Let's use mask to drop all 0 rows and redisplay the dataset. In this step, we choose to replace the negative ones because the player's guild status cannot be negative value. It could be 0 if the player doesn't choose to join any guild. Back to the guild value, since there are more than 1 million records in our dataset, we could choose to replace all those guild status that are -1 with 0 The reason we play this step after the previous step is to avoid mislead the guild list records. Imagine if we replace these negative values first, it might cause some all zero rows and all zero columns. After the restructuring of our dataset, let's check the level distribution. The horizontal bar plot indicates the activity of high-level players is much higher. This is quite logical because the access of a large amount of high-quality content, such as raid dungeons and some challenging quests, has high requirements on players' level and gear. If we want to check guild status, we can pull up the data. We can see large amount of guild list records because one player could own multiple accounts, so the large amount of guild list records doesn't represent all players. Let's say I have 10 players, let's say I have 10 tunes, one or two of them are in guild, other tunes might have very low activeness. So the second step is to build a simple recommender for future players. If you are totally a new player who has no idea how these game races and classes perform like, we would like to randomly pick a class to check with other classes or races, see if they are compatible with this one. The compatibility is based on the popularity we collected from the records. Let's go ahead and see. Here we found Tauren and Orc as your best races for warrior. You can replace this word with any classes or races you like. This is exactly what the real game word tells. The racial traits of Tauren and Orc are perfectly designed for melee classes, at least in 2007. If you don't like warrior, you like ranged classes, say mage. Here we can see the top race for mage is undead, which shows the highest correlation. For people who are not familiar with this game, the racial traits will change in every different expansion of this game. For example, the undead had a racial trait called Will of the Forsaken, which removes any charm, fear, or sleep effect and provides immunity to them for 5 seconds. Before 2007 or earlier, it was 30 seconds or 20 seconds. Now it's 5 seconds, but it still hurts, especially in PvP. So if you don't want to check classes, you want to check race. You don't care which class is strong. You don't care about damage dealing or anything. You're just 100% casual player. You only care about the look. Let's go ahead and check the so-called best looking race, Blood Elf. And we can see the best class that suits is Paladin. That's how the real game word tells. Many people chose Blood Elf just because it looked good. Our next step is using k-means clustering to help our machine learning. The major obstacle that we're facing is the large size of our data and the poor hardware environment. So we need to downsize our data a little bit by having the most useful values left. We have considered dropping some rows that contain zeros, but our data are largely scattered throughout more than 1 million observations containing no empty row or column. Finally, we decide to select records that has highest activeness based on previous horizontal bar plot in the scale of the player level, guild status, and instant records collection. First, let's select only the level 70 players. Remember the bar plot? It shows the level 70 players has the highest activeness. Second, let's sort data by guild status to get the most active players stay on top. And finally, we select only the top 100 records at our new data type. Then we drop the column level, since it already contains the same value, and rename the index. Get the output, 100 rows. Next, let's do feature scaling to transform the data into scales based on the standard deviation of each column in the table above. Then we use this Python code to help us to find the best k value. So on the elbow graph that previous code generated, when k increases, the average distortion starts to drop rapidly, then change to slowly at 3 elbow points corresponding to 3, 4, and 6, which could be the optimal values for k. After tested each value based on the adjustment of the major TS and E parameters related to the visual output, we assign the elbow value 4 to K and build the graph. Let's set the number of clusters that the elbow indicates above and generate a label for each data point. Finally, we use TSNE and bunch of Panda toolkits to help us build the 3D plot. Here are two important parameters that are strongly affecting the layout of our 3D plot. The first one is n_components, which indicates the dimension of the embedded space. And second one is learning rate. This is very important because if this value is too high, it will make our data look like very condensed balls. If it's too low, our data may look pretty uneven. So if the data points are too close to each other or too far from each other, we have to lower it a little bit. Here we are on the last part of the project, graph centrality. In this session, we are using Panda Network X to help construct our data frame. Firstly, we have to draw our network graph to analyze the centrality of the specific nodes. Here we use Gephi as the external program to help build the graph. The data set we're using is the original one because we need categorical values to create nodes and edges. Let's import the old one and make a little bit housekeeping. Then output the new file for Gephi. Now let's go to Gephi. This is a Gephi. We're using the software to help us to build the graph, then generate GML file to rebuild the graph and compare these two. We already have Gephi open and have our data set imported. If we check the data laboratory, we can see Gephi already built the ID, label, and type at the moment we import our data. The software also provides many different types of graphs. If we want it to look more spheric, we can use this shape. We can expand it a little bit, right? You can make a lot of adjustments on these parameters to generate a better output. Here we rank these nodes in different colors to indicate different importance of them. And we use different centrality to build different metrics. The first reason we use Gephi to build network graph is to help us prove the simple recommender we built before. These are the codes we use to find the best correlation for the chosen race or chosen class. Now let's compare the graph with these codes. We can find the results of the recommender perfectly match the color indication in Gephi graph. We can see Blood Elf has the darkest color, which corresponding to its position in the Python output. And the darkest color also indicates the top importance. Tauren is the best race for warrior, and we can find the connection between Tauren and warrior. The color of the edge also show high importance. Same thing we can observe in the mage part, which means the recommender we built is quite reasonable. Our next step is to use Gephi to generate GML file that Python could read and build networks. Gephi also provides us different approaches to find out how nodes are close from each other by calculating average path length for the network, which is the path length for all possible pairs of nodes. The software provides us 3 different attributes to build metrics for centrality analysis. The first one is betweening centrality metric. This type of attribute indicates how often a node appears on the shortest path between nodes in the network. And the second one is closeness centrality metric. It indicates the average distance from a given starting node to all other nodes in the network. The third one is X-centrality metric. It tells the distance from a given starting node to the farthest node. Now we're back to Python. Here we are importing a GML file, and Python will use this file to build its own graph and make its own centrality analysis. First, let's create a weighted graph and tells Python to use this graph for its centrality analysis. Here are a bunch of parameters we can use to adjust the layout of our graph. Our graph these dots looks pretty even, but they have the same value? This step displays the importance of the nodes, which is centrality. We can see from here, Blood Elf still a high rank, but we see a troll here. So the result shows a little bit difference compared with what our bar plot produced before. It is because of some attribute losing. During the import process, we have to pay attention to the file format because this file, the GML file, is generated by Gephi. If we choose export Gephi file and choose the GML format, save it with this extension, we will get a file like this. But the GML file has strict format requirements. First, there should be no carriage returned before the open square brackets. If we compare these two outputs, we'll find that these carriages are not necessary. It needs to be more indent. So this is the right output, this is the wrong. If we don't clean them, Python will have error output, which look like this. The reason we're easy to get this error is when Gephi generated the data for us, it did not tokenize these ID values, label value, and other necessary values. So we have to manually do it or use other algorithm. Also, during the file output, we might have messed up some setups and lost some attributes when we output Gephi graph into a GML file. So that could be a reason of the output difference between Python's centrality analysis and our previous EDA. So this is my data analysis project. It helped me learn a lot about machine learning and found a lot of space to improve. Thanks for watching and Merry Christmas.